I have my table here where I have 2 salespeople and some dates and some amounts. And what I want to do is to grab one single row for each salesperson. And let's just say I want to sort it by date descending. So I want the highest date first. And I want the first row where Naruto comes up. And I want the first for Denji, so I don't want that row or that. But my original sort order is going to be used when I remove duplicates, which I can show very quickly. Before I sort, if I add an index column, then you can see that I'm actually telling the truth. Because right now, my index column is based on my original sort order. And when I then go ahead and sort, I can see that my sort is now different. And if I just say remove duplicates on salesperson, here remove duplicates, then I don't get what I expect. I get 3 and 0, because if I go back to my added index, I can see that Denji's first row is index 0 and Naota's first row is index 3, and that's exactly what I get when I remove duplicates. In other words, my new sort order has been completely ignored, which is obviously not what I want, otherwise I wouldn't have sorted. So what I wanted to happen is to have this row where Naota has index 8 and this row with Denji where he has index 2. That's what I wanted, but that's not what I get. And I have 4 ways that I can solve this problem. And I thought this first option is a little weird, but if I add an index column right before, so this would just be index column 2, which now has my new sort order. If I go into remove duplicates, I will maintain my sort order. So you can keep the new sort order when you remove duplicates by simply adding an index column right before you delete duplicates. And method 2 is the one I've shown before, which is where using Table.Buffer function will load my table into memory. So if you have a big data set, then this can take a while, and it's also a little costly to do, again, because you're loading a table into memory to do one action on it. But all this would be is I first wrap my table in Table.Buffer, which doesn't do anything. And now I can do my remove duplicates, which was called table distinct. So now I've gotten exactly what I wanted, and the benefit again of this method is I have one step and I don't have to add an extra column just to remove it. But these two give the exact same solution. But I think this one might cost more, like it will take longer to update because you have to load the table into memory. Whereas this is just adding a new column. Of course, this is incrementing, so that might be expensive if you have very many rows. I've just done a little cleaning here because I want to show later on which method will be fastest. So at this point I want to do my remove duplicates using the group by function, and this is also going to give me the problem where it ignores my sort order, because right now that's my last action, and I can say I want all of my rows, and it will now be index 0, 1, 2 for Denji, but what I actually expected is it should be 2, 0, 1. So it's ignored my sort order again. And one other method, just like I did with index, where I could add another index in order to maintain my order, I can actually do the same thing here, where again I wanted that was 2, 0, 1 for Denji. And what I can add is, before I do my grouping, if I add a new column, not an index column, but just a new column, where I can just give one value, for some reason that causes the sort order to be maintained, so 2, 0, 1. And I don't know exactly why this is at all, but it works, but it's not exactly what I want to do. And I want to show this because this isn't exactly how I want to do things. This is sort of using a hack instead of solving the problem. But what I can do is now I want to extract only one record. In other words, the first row, because this has maintained my sort order after I've added the custom column. I want to add a new column because I have a table in this column. So I can say I want to go into the count, which is a table, and extract the first record. So curly brackets. And this will give me my first row, which again is now to 73 and index 8. And that is index 8. So I can expand this and say I don't want the original name as prefix and I don't want salesperson. I have that here. I can expand that and then I can delete my count. And this will give me exactly what I wanted, and then I can also delete that. So now I have the same result as I did before, but this is a lot more steps actually with group by. So I would prefer not doing that. And then a last option is to also do group by, but instead of specifically grabbing the first row, I don't have to do that, and I don't have to add this custom step, which I really would prefer avoiding. I want to grab the one that is either the minimum or maximum, whatever I base my sorting on. I can then say I want to use a Table.Min function, which normally when you do these from numbers here, where you do a calculation like summing up, you do it on a list, but this is a table, so that will return me a record. And just as before, I need to add that as a new column, where I can say table. In my case, I said I wanted to sort on descending, I believe it was. Yeah, descending on date, and since I will be doing the sorting inside of my grouping, I don't need that step. I can simply say add a new custom column where I say I want the table maximum function to grab the one record that fits my criteria. Yeah, returns the largest row or default value given criteria, and my table is count. So for each row, go into this column to find my table. I need to pass in a list because I can have multiple criteria. And my column inside my table, inside this column, is called date. And that is all I need. And then I think that should be everything, yes. Yeah. So that was index 2 for Genji, which is what I expected because that has the highest date. And that was 8 for Nyota, which is also correct. That's 30th of July. So now I have the exact same scenario as before. I need to expand this without salesperson because I already have that. And actually I can also just remove the index here instead of deleting it right after. And I can delete that and move that over here. And now I have exactly the same, except I lost my type for amount in case that's a problem. I don't think that is, but just to be sure, I'll add that as a fixed decimal number. And then I want to test which method is fastest, but in order to do that, I need to add some more rows because you won't be able to see very much just by looking here at which are fastest. Called Table.Repeat, which will make my table simply duplicate all of my current rows. So it would be better if I had more salespeople, since I'm grouping and sorting and so on, and that would make an impact if I have different salespeople. But it is simply called Table.Repeat, and my name is source, and let's just say I'll do that 200 times, which will make it a lot bigger. And I can add that as my second step every single time. It looked like there was a small performance difference, but honestly I don't think it's big enough to warrant really caring. Maybe it's different if you have actual different values, different sales people. But in terms of which method I would personally use, the method that I would definitely prefer is usually the one with the fewest steps, and also the one that's easiest to understand. And I don't think this group by and using tables and then you use a record function on that table, I don't think that's the easiest method or the one that makes most sense to people when they see this, because here you have a table in a row, and then here you're grabbing one row, and you're doing the same thing here, but it has more steps. So honestly, the easiest method would be to either add a new index column right before you remove duplicates, or just to add so that will maintain the sort order. So this is by far the easiest method, which is just adding a conditional column or just a new column, custom column. Now, whether you add an index column or custom column, it really doesn't matter. So since adding a custom column with the exact same value in each row, that should be a lot easier to handle. So this would be my preferred method. Add an extra column that you're going to delete right after, then remove duplicates, and then remove that column. Alternatively, you can do the Table.Buffer method, where you simply wrap the table in Table.Buffer, the Table.Buffer function, and then you remove duplicates. But this might be slower because you're loading the table into memory, and you only use this table once, so it's a bit of a waste. So I would definitely go with this method, because it's also very intuitive. If you just remember to add a note here to say, so since this method has a few steps, even though Table.Buffer has fewer, I think this one, as long as you remember to add why you're adding an index or a new column right before you remove duplicates and then delete that, then I think this is definitely the best option. So yep,